Good afternoon, everyone. Thank you for joining our webinar. Our topic for today is critical path in scheduling. Should you all have any questions, you can write it in the chat box and we will answer it during the question and answer session. Now, I would like to introduce the speaker for today, Ms. Clarin Yo, our Principal Solution Architect.
Hello, everyone.
Hello, good afternoon.
Hello, good afternoon. So, hello, welcome to our PCSS today webinar, Critical Path in Scheduling. So, a little bit of introductions about myself here. Okay, all right. So, my name is Clarin Yo Singh. So, my positions in PCSS is that I'm a Principal Solutions Architect. So my education background is that I graduated from Swinburne University of Technology, major in civil engineering. So besides involved in project scheduling work, I also involved in training and installation services provided by PCSS itself. So these are the topics that I will be covering for today's webinar. The first one is a little bit of introductions to what is critical path. The second one followed by critical path method scheduling technique. Then a little bit of understanding on network logic diagram. What are the relationship types involved in project, scheduling concept, total plots, and lastly is a little bit of demonstration by using Primavera P6. So now, what do we know about critical path? The question is, what is critical path? So basically, this critical path, it is actually the longest continuous path of activities from the progress data depth until the final completion activity, which determine the overall completion date of the project. So you can say another way is that follow the critical path. The example, let's say there is any of these. So indirectly, you know that your project finish date, they will be affected and will be pushed forwards from its original finish date. So this critical activity here, they are defined either by using the total plots or the longest path in the project network. So now, how do we want to calculate this critical path in the project network? So there's this scheduling technique. It is known as the critical path method scheduling technique. So in short, it is known as the CPM scheduling technique. So this CPM method, it is used to help to calculate the project schedule dates. So this schedule dates is the activity early dates and also the activity late dates, and also help to determine which activities in the project actually falls on the critical path and requires our immediate attentions in order for the projects to complete on its set deadline. So this CPM method, they uses two elements. The first element is the durations of the activity and also the relationships between the activity in order for it to calculate the activity schedule dates. So basically, these calculations, they are done in two passes. So the first one is through the forward pass, and the second one is through the backward pass. So we'll learn more about this later on. So before moving into the forward and backward pass calculation, let us understand a little bit about network logic diagram. So this is a network logic diagram here. Basically, the network logic diagram, it is a logical representations of all activities in the project, which show the relationship dependency on one another. So why do we use network logic diagram? So this network logic diagram, they are used to determine two things. The first one is to determine how much total plots each activity carries. And also once you know the total plots, you can then know the critical path of it. So as you can see here, activity A, B, C here, they are all in one chain. So in network logic diagram, you have predecessor activity and successor activity, right? So you can see here, activity A here, it is a predecessor to activity B right here. So activity B here, it is a successor to activity A here. So activity A here, it is an activity without predecessor activity. This means that, so before the commencement of this activity A, there is no activity before it. While activity C here, it is an activity without successor, means after the completions of activity, there is no more activity after this completions of activity C. So if you all have any questions, just put it in the chat box, yeah? Now we're moving on to the relationship types in the project network. So basically in Primavera P6, by default, the relationship type is finish to start. So activity B, it can only start once activity A has been completed. So the second one is the start to start relationship. So for start to start relationship, activity B can only start once activity A has started. The third one is the start to finish relationship. Well, this relationship is the least used relationship in schedule. So basically it is mainly used for maintenance work only. So for start to finish relationship here, B can only finish once activity A has started. So the last one is the finish to finish relationship, where activity B can only finish once activity A has been completed. Now, we have learned a little bit about what is predecessor activity, successor activity, and also a little bit of information on the relationship type. So now we want to learn more of the concept behind this critical path method scheduling technique. So as I mentioned earlier just now, this technique that involves forward pass and backward pass. So let us know more about forward pass first. So for this forward pass, it calculates the activity early dates. So this early dates, it is the earliest time for an activity to start and finish once its predecessor activity have been completed. But this calculation, it can only begins with activities without predecessors. So this is the formula where we can use to calculate the early dates, where early finish is equal to early start plus duration minus 1. So before we begin to understand more about forward pass, I have a question to ask. So let's say we have an activity starting today, 7th of August. So this activity, it has a duration of 10 days. When is the completion date of this activity? You can share your question in the chat box. So let me show here. So as I mentioned earlier, the activity is started on the 7th of August. So by using this formula here, you add in durations of 10 days. But you have to minus 1. So the completion date of this activity that falls on the 16th of August instead of 17th of August. This is because on the 7th of August, it is already considered the first day of the activity itself. So based on Project Management Book of Knowledge Guide, they also stated that the first day of project is considered as 1. So as you can see here, activity A and B here, the same concept apply here as this activity also occurs simultaneously. So the early start for activity A and activity B is equal to 1 here. So now let's use this formula right here, early start plus duration minus 1. So the early finish for activity A here is 1 plus 5 minus 1. You get early finish equal to 5. So follow the same formula for activity B here. 1 plus 10 minus 1, you get early finish equal to 10. So now we want to know what is the earliest start that activity C can start. So you can see here, activity A, B, C here, it has a finish to start relationship. So this means that activity C, it can only start once activity A and B here, both have been completed. So let's take a look at activity A right here. The early finish for activity A is on the 5th, while the early finish for activity B is on the 10th. So subsequently, it makes the early start date for activity C to be on the 11th. So using the same formula here again, 11 plus 15 minus 1, you get early finish equal to 25. So now we have learned about forward pass. So now we go on to backward pass. So basically this backward pass, it is used to calculate the activity let stat. So these let stats are the latest times an activity can start and finish without delaying the project finish date. Basically, this activity here, the calculations only begins with activities without successors. So let's say you have a project, there is no must finish by that. So the successor activity here, the let finish will be equal to the early finish date. So this is the formula to calculate let dates, where let start equal to let finish minus durations plus 1. Since activity here, for activity C here, there is no impulse must finish by that. So the latest finish date is equivalent to the early finish date, which is 25th. So using the same formula here, 25 minus 15 plus 1, you get a let start equals to 11. So now you want to know what is the latest finish that activity A and B here can complete without delaying activity C right here. So activity C, the let start is equal to 11. So the latest finish that for activity A and B falls on the 10. So using the same formula here, you get a let start equal to 6 for activity A and let start equal to 1 for activity B. So now we learn what is early dates, let dates, using the forward pass and backward pass calculations. So now we want to know more about total floats. So in Primavera P6, by default, it will use total float to calculate whether the activities are in the critical path or not. So what do we know about total float? So total float, it is the amount of time an activity can slip from its early start date without delaying the project finish dates. So let's say if the activities falls on the critical path, they have a total floats equal to 0, and the activity bar shown in the Gantt chart, they will be red in color. So this total float in the critical path, they are the series of activities which help to determine the project completion state. So in order for us to calculate the total float, it is the difference between the activity let dates and early dates. So if you use Primavera P6, you know that Primavera P6, it will help you to automatically calculate all the total floats and the schedule dates for your project, but you cannot edit the value of total float inside directly. So this is the formula to calculate total float, where it's equal to let start minus early start or let finish minus early finish. So now by using the formula here, let start minus early start or let finish minus early finish, total float for activity A right here, 10 minus 5, you get the total floats equal to 5. For activity B right here, 10 minus 10, you get a total float equal to 0. So for activity C right here, let finish minus early finish, 25 minus 25, you get total float equal to 0 as well. So you know that for activity B and C here, they have a total floats equal to 0. So you know that two of these activities, they are critical. So the critical path in this project network is activity B and C. So let's say there is any delay to either activity B or activity C. So indirectly that you know that your project finish date that will be affected, will push forwards from its original finish date. Okay, now that I have explained about the concept behind this scheduling technique on how we can calculate the early dates, late dates, and also total float, right? Now I want to show you how Primavera P6 can help you to calculate these early dates, late dates, and total floats automatically. So before this, we want to bring out the early start, early finish, let start, let finish, and also the total float column out. So what we can do here is that just go to layout here, click on layout, then you go to column. So inside column here, you expand the dates tab here. You search for early start. Then you double click it to assign it to the selected options. Then you click on early finish, let start, and let finish as well. Next, we want to bring over the total float. So expand on the durations tab here. Look for total float to bring it over. Then click OK. So you can also drag your Gantt chart window to the right. Now you can see here, your early start, early finish, let start, let finish, and total float column has appeared. So in Primavera P6, there is also this engine called the critical path method engine. So basically what this engine does is that it will help you to automatically calculate all these schedule dates, total floats, and also will push forwards all these activity bars to the calculated schedule dates. So just go to options here, tools, click schedule, or you can also click F9 on your keyboard. So just click schedule here. So you can see here, P6 has already helped you to calculate automatically all these early start, early finish, let start, let finish, and also all the total flows for all of these activities here. So after the calculations are done, all these activities here, they have been pushed forward to the calculated schedule dates. So let's say we take activity piling here. You see the total float here equal to 0. So from what we learned earlier, total float equal to 0 means critical. So the Gantt chart bar here is red in color. Next, pick activity drains. So you see the total float here is 6. So this is not a critical activity, so the bar is green in color. So there is also an options where you can allow P6 to calculate the schedule dates and total floats automatically without for you having to click on the schedule every time you want to change your activities, durations, and relationship. So go to schedule, you click options here. Then you see this option, schedule automatically when a change affect dates. So mark on the checkbox, click close. So for example, we take example piling. You change the durations then. So just press enter. So when you use this function, right, you can see that P6 has already automatically calculated all these schedule dates without for you to click on schedule button or F9. So if you don't want to use it, you can always go back to schedule, go back to options, and then just uncheck the box. So as you can see here, like I mentioned earlier, for total floats equal to 0, the activity bar is in red in color. So for total floats equal to 6, the activity bar will be green in color. So that's all from me. Thank you. Any questions?
Thank you, Clarin, for giving us information on critical path in scheduling. Is there any question from the participants? Then we can answer it. You can ask the question from using the chat box as well. No question. If there's no question, we're gonna move to the next slide.
Hello, is it
Okay,
audible?
hi. Yeah, I can hear you.
Actually, my headphone is not, but receiving the voice, but not producing my voice.
Oh, okay,
Myself,
I can hear you clear now.
yeah, myself is Mohammed Mujib Akhtar from India. Okay.
Oh, I see. What's the question that you want to ask us?
My question is, actually, I joined a little bit late, so I want to see the slide which is shown before start to finish and finish to finish. Actually, I want to understand the basic concept of start to finish, and finish to finish. This is my question.
Then I'll expand on the relationship one more time then. Okay.
Yeah. This one. Yeah.
Okay. So in Primavera P6, right, by default, the relationship is set to finish to start every time you link between two activities. So for finish to start here, let's say you link it like this. So activity B, it can only start when activity A has been completed. Okay?
Okay.
So for start to start relationship here, since you can see that A and B, they start simultaneously, right? So activity B here, it can only start when activity A started, okay?
But means both activities should start parallelly.
Yeah, if you assign this S to S relationship here, it means that both activity A and B, they will start simultaneously at the same time.
At the same time, okay, understood.
So for start to finish relationship here, but this is the least relationship used in the project, okay? So basically here, activity B here, it can only finish when activity A has started. So basically this relationship only used for maintenance work.
Only for, sorry. Start to finish means B activities will finish, then A will start.
Yes, activity B can only finish when activity A started at the same time.
Oh, at the same time, okay.
Yeah.
Okay.
So for the last relationship right here, finish to finish relationship, right? So you can see the arrow point down here. So basically right here, activity B here, it completes once activity A has been completed. So this one also completes simultaneously at the same time, same period.
Well, means both activities should finish at same time, right? I'm saying both activity should finish at same time.
Oh, wait. Let me explain, okay? So when activity A can finish, when activity A finish, then B can finish for finish to finish relationship.
How can I understand that both activities should finish at same time?
So for finish to finish relationship, right? Doesn't mean that both activity here finish at the same time. It means that activity A here finish, so activity B here also finish, can finish.
Okay. Okay. Proceed. Thank you. Thank you very much.
Oh, no problem.
So is there any more question from our participant? If there's no more question, I have our next upcoming class on project management in Primavera P6 resource on the 21st of August 2020, which will be held in our PCSS training center in Kuching. And then we also provide services such as vendor work program, master work program, as well as monthly project control to those who want to engage us for their project. So for the project. And then these are the list of training that we provide. We have planning, scheduling, and controlling. Primavera P6 training in basic, resource, as well as advanced. and Synchro 4D training as well, basic and advanced and PMP certification bootcamp. And then we provide software as well. For example, Synchro software as well as Primavera P6 software. And then, so if there's any question about our services, do contact one of our consultants to find out more about the trainings and services that we provide. All right, thank you for everyone that participate in our webinar. Hopefully that you guys can learn something today. So thank you so much.